What's up, guys? Welcome back to Vanover Machine and Repair. Today's video is going to be another really cool one. We have this nice beefy stock and we're going to be making 2 pins and 2 new bushings for a larger demolition grapple hook. Let me bring you in closer and show you what we're going to be doing. Here's a closer look at the old parts. So this grappler uses 2 of these pins with these tags welded on the back. These tags are 3/4 inch. We have some nice 3/4 inch plate here. We're going to burn those out with the plasma cutter and then we'll rotary weld these on. And then the actual shaft itself is 6-inch nominal dimension and it's undercut. I don't know if you can see it, but probably 30 thousandths here. And then these bushings are bronze bushings. This one was cut. It's not normally split. Has oil groove there and it has indentations here, so that's going to be nice and fun, and then a center oil groove. So this bushing is probably going to be, you know, the more fun one to make. And then the fit on this is very nice. It's not loose at all. This is exactly what we need. So yeah, we're going to fix that. In terms of the material, this is going to be made, the 2 bushings, out of your standard bearing bronze material. Cost-wise, in case you guys are curious, about 500 bucks for this piece here. We're going to make our 2 bushings out of that. We got our plate, that's just normal hot roll, pretty cheap. And then we have a nice piece of 4140. This grapple hook is under a lot of stress, so we opted to go with 4140 instead of like a 1045 or a different material, just to increase the wear life. There is a hole on the center of that that is not critical. But we are going to be adding one back. I was unable to get a hollow bar, so we are just going to be doing some heavy drilling to get that hole back in there, and it is what it is. Other than that, I think the first step is to get this cut down so that way we can work with it in the lathe, and then we'll start machining the pins first. All right, probably one of the most annoying parts about this job is drilling the holes. We got to drill a hole clear through about 10 inches, and it's got to end up being about 4 inches in diameter. So we could do this on the lathe, but it's a lot of cranking, and ultimately I'm trying to automate as much as I can to try to cut down on the work I got to do. So we're over here in the radial drill. We're going to come in with this pilot bit. I don't know what size it is, 3/4, 13/16 it looks like. And we're going to drill as far down as we can. Now ideally I'd have coolant set up over here, but we don't yet. We're working on that. We'll oil it, we'll run it slow, and then we'll switch to a bigger 2.5 inch, I believe it is, drill bit and finish it out. And we may have to flip this over. Now I know this seems like it may be less efficient, but the benefit in doing it on this is once I get this deep enough where I can fill the puddle of oil, hopefully I can kind of walk away and do some other stuff while this drills. Whereas on the lathe, I got to be turning the hand wheel constantly. So we're working on getting coolant, but until we do that, we're going to do something like this. We'll see how it goes. I feel like we may be asking a lot out of the drill, but we'll give it a shot. We're running 252 RPMs. It's like an 8,000 speed rate, a fresh sharpen. We're not breaking a chip. Let me step up to 15. Wow, that's speeding fast. I like it, super smoky. Wow, we're gonna have that hole done in like a minute. It'll be rough on the start. I'm fine with that. It'll get better once it smooths out. So I'm gonna bump it up to 8 thousandths. There it is. See how it wants to walk? Let me actually kick it down to 6, see if it improves. We got our material chucked up and we're ready to do some heavy turning, and boy, do I have a treat for you guys today. We have a new tool in the shop and we're going to be putting it to work. I've actually been testing it out and I have blown a fuse on the lathe, and I've never done that in 4 years, just from the amp draw. Now obviously I stalled the machine and we don't want to do that, but the point is I was pushing our new tool. Before we get into the new tool, let's talk about what you've seen me use in a couple of inserts. So typically, these are the 2 tool holders that I use for 90% of my turning. This is a CNMG 432. 2 is the radius on the end. I use that for most of my roughing and even some general finish passes. It's a good all-arounder. A 433 would be better for roughing. A 431 would be better for finishing. And then when I'm done roughing, where I want a finer finish or to get into a tighter spot, I'll use this DNMG tool holder, a little bit less durable, but still very durable. And really, I prefer the CVD type coated inserts. They have like a black coating on the top, and that really just helps with high heat buildup. On this one, we're using a Kyocera set of inserts. It's a 431. And this is a CA 125P grade. Very nice insert. I got these cheap, but I really like them. They're gold with a black top, and great insert. But that's not the point of today's video or the star of the show. So I ended up picking up some new inserts. I was using these cheap Iscar ones that I got for $1 each on eBay. And I picked up these bad boys, and I paid retail for these. And these are the same style that I really like. So it's the CVD coating, I believe it's called. You can see there's gold, and then the black on top is that extra coating, which really helps with heat retention. Now these are a 433, so an even larger nose radius. They're going to do super well on roughing and be very, very tough. And I believe these inserts are like $20 each. And basically, this grade is a CNMG 433. MP3 is the chip breaker style, and IC 8250 is the actual grade of carbide, which is a very tough carbide. And I really like the IC 82 grade. It's a very good grade. So unfortunately, or fortunately, we're not going to be using these or testing this in today's video because we have an even crazier tool that we're going to use. And that is this guy. Just as a size comparison, here's the old one, here's the new one. Here's the shank, here's the shank. So I picked up this ISCAR 1¼ inch shank PCLNR 20-5X, and we're getting ready to do some real work here. I've already given this guy a test run like I talked about. You can see we already got some nice discoloration on the insert. This insert, these are bad to the bone. This is a CNMX 553. Chip breaker is M4PW, and that grade again that I like, IC 8250. So this guy, let me just tell you, very exciting here, has a maximum depth of cut of 0.315 or 630 on the diameter, so over a ½ inch. Now I can tell you just from running this, this machine won't do it. It really will not do it, but it will do about 500 thousandths off the diameter. So we need to bring this stock from 7 down to 6, and we're going to do this with 2 passes on this guy, and then we're going to finish out with a DNMG just for surface finish, but we're going to do some really heavy metal removal and really push this machine using this guy right here. So first we're going to get this piece faced off, and we're going to get some tailstock support, but then we're going to get real aggressive and make some really nice chips and put this machine to work. So I just wanted to take some extra time and talk about those inserts because I know you guys really want to hear about that and what we're running. So let's get this material faced off. We got the machine switched back to standard so I can give you the surface foot because I know you guys like that. We're just going to face this off. We're using the cheap 432 inserts. Now, because our hole is not concentric, we're just going to come in here with a boring bar and clean it up just on the end, and then we'll chamfer it for our center support. Actually, it looks a lot better on this piece compared to the other one. Now this angle is not the same angle as the cone center, but it will still work, and it is concentric. Just saves us a little bit of time from having to move the tool post. All right, Paul Brown, this is for you. We're taking a ½ inch depth of cut in one shot as well. So let's get to work. Okay, that's not aggressive enough. Couldn't remember if it was 7 or 14. I think it's 14. So now we're doubling the feed rate. We're going to see what we got. It's a little much, I think. All right, we're down to a 11th thou per rev, ½ inch depth of cut, 144 RPM. Let's give this a shot. Now this chip isn't fully optimized. It's not bad. But with a little bit more power, we could run it a little faster. But I'm at the limit of the power on my machine, so it's doing work. But it could do more work. Look at that spring back, nothing. Next, we're going to take about 400 thousandths off. This material actually was a little bit oversized by 60 to 80 thousandths. So we have about 600 to come off to get down to 7. See if this machine stalls on us. Definitely a different type of chip. You can really tell this insert wants to eat. Our surface finish is better, moving faster. You always want to rock the micrometer, find the high spot. We've done our roughing. We're going to come in here and do our 2 finish passes. Now when you're roughing, dimensions don't really matter too much. Obviously when you're doing your finish passes, your part needs to be relatively cool. It can be warm, but if it's too hot to touch, then you're going to have a lot of movement. Obviously bigger parts are going to move more, so take that into consideration. The most important thing, if you're learning, that can always get you is taking your cuts and overshooting or undershooting your measurements. The way you prevent doing that is to split the load on the last cut or last 2 cuts. So if you come in here and you make a cut and you have 100 thousandths to go and you advance 100 thousandths, you're not going to take 100 thousandths off because there's some deflection that happens with the tool. So really what we need to do is we need to take 215 thousandths according to my measurement. So I will divide that in 2 and I will take that on this. Now we switch tools, so it's not going to be completely accurate. It'll be off a little bit, but it should be close enough that the load is split and therefore the tool deflection is split. So our measurement should be pretty accurate. The problem comes when you're roughing, you switch tools and you just go for it and you don't split it in half, and the tool pressure is vastly different. You've seen how the other tool, once we were done cutting and we pulled away, it didn't even drag the work. It was almost 10 thousandths away because the tool is sucked in during the cut. So this is very crucial if you want accurate parts on a manual machine. So we'll come in here and we'll take, I don't know, what is that, 107 thousandths. Then we'll measure it without moving this and we'll make our adjustments. We're going to be running 615 RPMs and I stepped the feed rate down for surface finish. So we're running about 10 thousandths per rev. So I just barely kiss it and we know that we're at 6.215 and we're going to take about 107 off, roughly. We're going to come down to 6.107. We'll take the whole cut and then we'll measure it. See how we did. There you go. That insert is probably 90% optimized. That surface finish is maybe going to get 5 to 10% better, but it's pretty much there. Very important that you do not touch the tool post at this point. Come in here and take a measurement. We'll take our time. Should be close. I'm going to say probably within like 5 to 7 thousandths of where we need to be. That feels right, okay? Look at that. You probably can't see it. 100 thousandths and 9. So we're within 2. That's pretty dang good. All right? But it's not perfect. Now, if we followed that logic, what we would do is we'd adjust our DRO for our difference. Right now, our DRO, you can't see it. It's reading 6 inches and 110 and 2/10. Very close. So we're going to come up here and go 6.109 set. So now that should be dead on. Now it's not, but we'll get to that. Now if you were making this part plus or minus 5 thousandths, you could just roll with it here, feed in the rest, and you're going to be fine. Probably within a thousandths or 2. But there's one other trick that we're going to do to try to get this as close as possible. What we're going to do is we know we're going to be putting a heavy chamfer on this part, so we're going to feed in what we think is the right amount based on our calculations. We'll take a cut that's an 1/8 inch over and we'll measure that. And that will tell us if we need to make any final tweaks, either a thousandths or 2 thousandths, either way. Now in this case, this is a grappler pin. We could be 10 thousandths off, doesn't matter. We're just trying to hold ourselves to a high standard for learning and getting better. So that's what we're going to do. Now, I can tell you from experience, this part is warm. Now it's not hot, but it's warm. It's going to shrink maybe a thousandths, maybe a thousandths and a half. I'm not worried about that in terms of our measurement, aside from I'm just going to try to shoot for 6 1/1000ths. If it shrinks a little bit more, it's not a problem. With experience and knowing the materials, you can sort of wiggle it. I mean, we're going to get this part within like a thousandths or 2, which is way, way good. I'm just showing you the process I would go through when I'm making a part, especially if I'm trying to get it fairly accurate. So we have our DRO set to 6.0015. So I'm going a little over, and we're going to make our cut and see how it goes. There it is. Now we'll double check. And this should be pretty close, probably within a thousandths if you're doing it right. Dead on. Probably can't see it. It says we're exactly 1/1000ths over, maybe a thousandths and 1/10. I'm happy with that because I know it's going to shrink just slightly. So we're going to roll with it. And once we're done with the job, we'll see how our measurements finished out and you can see how much it shrank. Now when we finish our cut, we don't want to drag it back over our nice surface finish. See how I do a quick feed there? All right, this is about to get boring, and I'm not just telling a joke. We're going to bore the inside of this hole. This hole doesn't matter, much like most other things on this part. But it really doesn't matter. It has zero purpose other than maybe to help lighten the part. So we're going to bore this out to 2.5 inches roughly. And in terms of tooling, we're going to be using one of these Valentine anti-vibration bars. We're using a DNMG style insert. And if anyone out there has more heads they want to get rid of in this size, let me know. These are discontinued. And I got a good deal on eBay. Basically, they're supposed to help cut down on vibration. They work pretty well, and these anti-vibration bars are very expensive. So I got these cheap because they're kind of discontinued, so you really can't get the parts for them, but they're pretty good value for money. So there's a little thing on the inside that sort of vibrates at the same frequency that occurs during boring. and sort of offsets the sine wave or whatever of vibration and minimize chatter. Almost there. Next step is to get this sawed off. We did a really nice job on our surface finish here, so we're just going to tape this up so that way we don't damage our finish, scratching it over at the saw. This is a new customer for us, so we really want to wow them if we can. Using these Vice soft jaws. Got this idea from Curtis. Thank you for that idea. MG 432. We were really close to drilling all the way through, so we just got to come in here and just open up that hole just slightly. We got both pins done. They turned out banging. They look amazing. Next step is to manufacture the tags. So we're just going to cut those out with the plasma cutter and get those rotary welded on, and then we should be done with the pins. 3/4 hot roll plate, A36, 8-inch wide. We're going to get these bad boys on here and get these traced out. All right, we're ready to buzz these out. Now I'm gonna be honest with you, my plasma skills are a little lacking. I'm learning, but I just don't have the time on plasma that I do on other stuff. So I did make this jig a while back. This will actually help us cut up. I already had it set up for 8 inches. So we'll go ahead and try to use this to buzz out most of the radius. And then we'll come in here and freehand the center. Freehand is where I'm not as good. And then we'll need to freehand these as well. So these don't matter at all. The old ones were flame cut. These ones will be flame cut. I'm gonna try to do a good job, but we'll see what happens. All right, we got our tags done and we're gonna move on to doing our bushings. We have this piece of 8 1/4 inch. We gotta make 2 3-inch pieces. We have just barely enough material to chuck it up in the machine. The inner ID is supposed to be 6-inch plus some meat. So we only have about 80 thousandths to take out of there. And on the outside, it's 7-inch plus some meat. So there's about 80 thousandths oversized, but we're going down to 6 3/4. So we're going to start by roughing the OD. Once that's done, we'll get the ID. The range here isn't too critical. We want this to be at exactly 6.750 plus or minus 2 thousandths. And then on the inner diameter, the customer is speccing 20 thousandths oversized from the pin, just so there's room for grease and misalignment. So that's not that critical. The OD is probably a little bit more critical. So let's start by getting the outside machined off. We're running 615 RPM, I believe an 8 thousandths speed rate. we got our stare-it micrometer here. We've been using 6 to 7. All right, let's see what that is. Okay, so that says that we're 2 thousandths over. All right, it's about to get boring. We're using this same boring bar. I switched out to the same style of insert I was using before, and I touched up the edge on my diamond slow speed carbide grinder. So hopefully that honed edge will give us a decent surface finish here. And I think that was a 907 grade ISCAR. So we're gonna come in here and touch off. We don't have a lot of material to remove. I think it's like 80 or 100 thousandths. So we'll get a cleanup first so we're fully round, and then we'll take a measurement. This is gonna ring like a bell, so here's a trick that I've used sometimes. Take a rag or something. Piece of rubber is good. Take a bungee. Certainly a lot better. I am going to measure that to be safe. All right, we're going to take our final pass. I flip my insert around to the other honed edge. We're right on size at 6 inches. So really, we're just going to take the clearance out. So I'm going to advance it about 20 thousandths on the diameter, take a cut, and we're going to call it good. I'm going to step the RPM up to 1,000. The faster RPM does sometimes help with bronze and aluminum.
Surface finish doesn't look bad.
All right, for our final measurement, we're just going to do it with a caliper. This is not that critical. It's key if you're doing this to rock your caliper to find the largest spot. All right, the largest number I had was 17 thousandths over, which is within spec. I'm going to confirm that measurement with a second caliper. I'm getting 17, 18, 19, which is perfect. And I'm aware that my insert is in the best shape. It'll work for this. We're ready to cut the internal groove. It's going to be much of the same on the external groove. We're using a Kennametal top-notch holder with a grooving insert. So we've already touched off the end. We're going to plunge in, and then we're going to jog to each side. It's about the same width, so it'll be the same move. Got a a nice groove down in here. Turned out really good. It has a radius on it, so we don't have to chamfer it. This next part's going to be kind of interesting. I've never done this before, but we're all coming along for the ride. So the old bushing has 4 cross grooves here, and they don't go all the way to the end. So if they went all the way to the end, I was thinking maybe you could come in here and try to slot them with the lathe. It's bronze, not a big deal. I have an idea, and we're going to try it, and we're going to see if it works. But before we did that, I wanted to be able to index this 90 degrees. So I took this tool and basically made a mark, and then ran it all the way over to the end and made a mark. So we'll do our operation here, and then we'll spin the chuck 90 degrees, and I'll set it up with a machinist square to verify that it's 90-degree rotation. The chuck has enough mass and it's in a medium gear that it's not going to want to spin on us, and we're just going to give it a shot, see if that'll work. We are ready to cut our grease cross grooves. Some of you guys are going to love this, some of you guys are going to hate this, but this is what we're going to do. So we have a pneumatic angle grinder extended neck where I've machined this portion down so it fits in a standard Aloris tool holder. I've used this to do ID grinding. It works quite well. We have a brand new carbide rounded burr on the end, and I made a modification bracket that adapts this to this at an angle so we can get this in here for clearance. If we were going straight in with the diameter of this collar, it would rub on the bushing bore. So I've went ahead and touched off either side and found the center. And what we're going to do is we have 2 jam nuts here that are going to set the maximum travel of depth. When I'm ready to lower it, I'll loosen the Aloris post. I'll run this nut up. That's going to drop our cutter somewhat precisely until it bottoms on this. I'll lock it. The position will be fixed. And then we can feed forward 875 and back to the center and backwards 875. That should, in theory, give us basically perfect grooves. The only thing I can see going wrong is maybe that bit gets gummed up with brass, but it is brand new. But other than that, I think that is the best way in my mind I could machine these grooves as perfectly as possible and as efficiently as possible. So we're going to get this fired up. Clamp the handle on, lower it down, and get to it. Well, that turned out to be a failure. I come up with another idea how to do it over on the milling machine. It's definitely unconventional, but I did some testing and I think it's going to work. So what we're going to do is we're going to get this chamfered on both sides, part it off. I'll get the other bushing to the same point, and we'll meet you over at the milling machine to hopefully address our mistake. This is what we're doing, and it's going to work. So we have our head leaned. The degree doesn't matter. Looks like 20 degrees or something. Doesn't matter. It's just for clearance. I made a shrink fit extension tool holder. So it's a 7/8 ID or OD, sorry. and it's a 1/2 inch ID, and it's 5/10 undersize. I heat it up cherry red, I slide in the end mill, and when it cools, it grips the end mill, allows us to have extension we need so we can get in there and make this cut. So we're gonna start in the middle, and we're gonna make our cut down and up, and hopefully clean up our boo-boo. I haven't decided if I'm gonna make one of these deeper or 2 of them and then 2 of them shallower. I wanna try to, hide our mistake, and it doesn't really matter too much. So let's go in there and get this cut out. Well guys, that's pretty much it. We got the tags done, we got the pins done, we got everything welded together, we got the bushings done, we got it all painted, and honestly guys, I think it turned out fantastic. I mean, maybe there's a better way to do this. I'm sure there's always better ways, but I don't know how much better to make these. These are, as perfect as I could physically think that they could be. But I'm sure you guys will let me know down below in the comments. We have the old pin here, major difference. The old bushing here, that bushing has 20 thousandths fit, a little lighter actually. I think it turned out to be about 17 thousandths. That's exactly what the customer wanted. And overall, everything turned out really good. We mic'd these, sorry I'm not showing them to you, but they were like +1 on one and -1 on another, so 60001 and then 59999, and both bushings are the same within 5/10 because we did them in the same op, both the OD and the ID, and I'm pretty sure we came out to 6.7490, so we're 1/1000 under what we were shooting for, so that'll still give us, I believe, about an 8/1000 press. Please correct me down below or offer me guidance on the press fit of these. The customer wanted to know if he could shrink fit them using some dry ice, or I'm sorry, liquid nitrogen. I told him that 8/1000 on that diameter and with it being bronze shouldn't be a problem, but I'm curious to know what you guys think about that. Other than that, I think when he mic'd them, he was getting like 641. We did 649, that's about 8/1000. And usually I go between 1 and 2/1000 per inch. So I think that ended up being like 1.3 per inch of press. So I think it's fine. So we should be good there. Overall, the job went relatively smooth. Let's talk about some stuff that we learned, some stuff that went well. machining these pins worked super well. The new insert that we used, I really liked it. Removed the material quick and efficient, minimal heat, definite good material removal rate, so that was good. Other than that, drilling the holes. We need to get more efficient at drilling the holes. We talked about the coolant setup that I need on the radial drill and or this machine. Ultimately, that's probably the worst part of making the pins machining wise, is getting those holes drilled. And really, I'm getting busier, which is good, but I'm not going to stand here for 30 minutes and drill a hole. It doesn't make any sense. So if I can automate that at least a little bit, that would be ideal. And the best way to do that is to be able to set it up on the radial drill with a feed, or be able to set it up here and attach the tailstock to the carriage, and basically do a tag-along tailstock. So I can run coolant, I can basically hit the feed and walk away, monitor it, but be able to do something else while it's drilling. And if it takes 20 minutes, it takes 20 minutes. It doesn't matter, but it's doing it without me standing there. So we definitely need improvement on that process. More of that to come in the future. We got actually a lot of work we need to do to this machine. The machine runs fine, but I need to level it. I need to do a coolant pump. I want to switch the motor to a bigger motor. I want to move it. I want to add a jib crane. I want to do a chip pan. So look out for that. At some point in the next 3 to 6 months, we're going to be tackling that project, because at this current moment, about 80% of the work I'm doing in the shop is with this machine. So I really want it to be better optimized. So there'll be some projects on that in the future. As far as the tags, my plasma work was better than it was on the last job, so that's good. We used a circle guide to cut out this. That made a big difference. The inside I did by hand. I was better than I was last time. What I'm learning is if that plasma tip is clean, it makes for a cleaner cut, obviously. But as you get better, you learn that, oh yeah, maybe my tip is dirty, so my pierce isn't as thin and clean. So we were able to get that all squared away. And for the most part, it turned out really good. The game plan on these should be getting these plasma cut, either by owning a plasma table or building a relationship with a company. Doing these freehand, not too much of a time suck, but the time it takes and the quality you get from a machine doing it makes a big difference. These look great now because I spent 20 minutes on the belt grinder just cleaning up the radiuses, but that's not needed. And that was needed just because my plasma cut was a little rougher than I wanted to deliver to the customer. So I'm not sure what we're going to do yet. As much as I want a plasma table, I think there's a lot of merit for not having one and just building a relationship with a company to do it, so I don't have to store sheets and do that. It's just another machine, but I haven't found a company yet who can kind of do this stuff relatively quickly. So we need to optimize that process. So that's the pins. As far as the bushings, worked pretty well. There's nothing too crazy with that. Everything was pretty smooth. The only major gotcha was our cross hatches. Most people aren't going to do that. That's extra work and probably unnecessary. I think a spiral would work out just fine. I wanted to keep them factory. The idea I did with the carbide burr and the pneumatic angle grinder or grinder, whatever you want to call it, didn't work. I think it could work under the right circumstance. Maybe a bit that has less gumming for this bronze and maybe taking a less aggressive cut. But ultimately, the milling machine was the play. Like I mentioned, I spent 2 hours maybe making that shrink fit tool holder. I've done it before. You can do it. Kind of sucks. When you're doing that, it's good because it gives you the extra reach. If I were to take the quill and kind of come down here, the nose of the quill would be too big, so I wouldn't have the clearance I need. They don't really make like extension tool holders that I found that have a really skinny nose. I've seen them on the Taper 50, I have those, but on an R8, I haven't really seen anything like that. A set screw is usually what they use. So in my case, what I did was I machined it over on the blue lathe, and I tried to get it about 5/10, 2/10 undersize. I heat it up red hot, slip the end mill in, let it cool, it grips it, and it's really low profile. In the past, I have just left the end mill in there, so I don't know how easy it is to get out, but I think, you know, if you heat it up quick enough, you could probably get it out. So worked out really, really well. The problem is when you're trying to make a 1/2 inch hole and you're trying to make it within 2/10, you can use a reamer, but a reamer will follow whatever the original hole is. Probably would have been fine, but I really want it to be concentric, and so on that lathe, the quill is a little bit iffy, has a little play in it, even with the lock on. And so sometimes my drill will sort of drift off center, and I really didn't want my hole running unconcentric. So basically, I bored it out, and it took me multiple tries. So other than that, we got that dialed in, we got it wrapped up, and it turned out phenomenal. I could not be happier. Overall, I'm really happy with how this job turned out. Curious to hear your feedback. And yeah, I know the customer is going to be happy, and these are going to provide a long service life. So if you enjoyed this video, let me know down below in the comments, and we will see you in the next one.